Hello, we're going to look at deleting nodes from binary search tree. And we're going to do this by you looking at some examples. So let's look at this binary tree and let's say we want to delete the number 1. Well, the number 1 is straightforward. We can just delete number 1. So the parent number 2 would just be pointing to known. So the pointer will point to known and we just remove number 1. Let's look at another example. What about if we want to delete the number 2? So 2 has 2 children. Now this is a little bit simple because 2's got only 2 children and it hasn't got any grandchildren. So it hasn't got any node coming out of a node. So 1 and 3 are the leaves. So in this case, you could say, what about if 1 replaces that spot? So we call that the successor. Who's going to be replacing the node you're removing? So we're going to think, well, if you have 1, 1 could now be the child of 4. And that binary search tree rule still is maintained. 3 is on the right side and is bigger than 1. You could also argue and said, well, I could replace 2. So we could have 3 as the successor. So 3 is now the child of 4. And that rule will still be maintained. 1 is smaller and it's on the left side. And 3 only has 1 child. But what happens if you want to remove a node like 12? 12 is right here. It's got 2 children and those 2 children has their own children. And somebody could say, well, who can the successor be? Now, if you're thinking of the number 10, if we choose 10 as the successor, remember 10 has 9 and 11. So what's going to happen with 9 and 11? So now we have a problem. 10 cannot have 3 children. Because of the binary search tree means that at most the number of children a node could have is 2. And we do have the same problem if we choose the number 14. So let's say we choose the number 14. We still have the number 13 and 15 that are lost. They don't belong to anybody because we can't just join them to 14. 14 is not allowed to have 2 children, 10, 13 and 15 as its children. So now we're going to think and say to ourselves, okay, if I want to delete the number 12, I'm going to look for the smallest node on the right side of 12. So the right side of 12 is this set of nodes. The smallest number is 13. So we're going to use 13 as our successor. So in this case, 13 is going to be the child of 8. All right, and let's see if that rule has been maintained. Well, 14 is bigger than 13 and is on the right side. 10 is smaller than 13 and it's on the left side. So we have solved that problem. Your turn, think about it. If you delete 4, who is going to be the successor? So if we delete 4, we look for the right side and we look for the smallest number, which is 5. So now 5 is going to replace the number 4. So now 5 is going to be the child of 8. And the rule, the binary search tree rule, is still being maintained. This side is bigger, that side is smaller, and we still have 2 children or less. What about if we want to delete the number 8? So that rule kind of applies to any binary search tree. We're going to still look for the right side of 8 and look for the smallest node. So in this case, it's 9. So we're going to replace, and 9 is going to be the successor. And that rule will still be maintained. You could also think, well, if you look on the left side, So if you look on the left side of 8, we could look for the biggest number. So the biggest number here is 7, and we could then use 7 as the successor. That rule will still be maintained. Now, if you noticed, our binary search rule, we've been lucky in this case, which we've had the number 7. But usually when you do this algorithm, you are actually picking a leaf. So the smallest number or the biggest number you're looking for would actually be a leaf. So that is our answer for replacing, or sorry, deleting the number 8. Now, if I look here and I want to delete the number 10. Now, number 10, if I look on the right side, the smallest number is 20. Now, in this case, 20 is not a leaf. So we have to be careful here, because if we do choose 20 as our root, 20 now has to be pointing to 26, because 20 only has one child. So 20 would now link to number 26. 20 is now the parent of 26. If you're looking at the left side and you're looking for the biggest number here, which is 7, you are likely to also do the same thing. 7 is now going to be the root, and then because 7 has only one child, we would then link 7 to 3. 7 is now the parent of 3. Okay, we're doing really, really well. I hope that has been helpful. If it has been helpful, click the like button. Thank you all. See you soon.